Yes, sir. We have taken other chapters.
Check it. That's not an issue. Okay. So that means we have completed half chapter with the other teacher. That's what you're saying, right?
Yes, sir.
Who's your teacher, by the way?
Sir, Amna ma'am.
Okay, Amnam. Okay. That's great. Okay. So, why is Halima basically entering the class again and again? Halima, do you have network issues in? Sorry, Hadia.
Yes.
Hadia.
Yes, sir.
Like, do you have any network issue?
No, sir.
Like, you are basically trying to enter in the class. Is it Halima is basically you, Hadia?
No, sir. Halima is not like my name is Hadi and my name is Tayyabe. There is no Halima over here.
Okay, maybe there is some sort of a restaurant. Okay, let it be. ठीक है बच्चों. So now let's start the class first of all. Now let's talk about the electric field lines. Okay. So as you've studied electric field and you have talked about that whenever charge is there, so it basically creates a region around it in which the you can say electric force is experienced, right? Suppose that if you're in a region in which basically electric heater is switched on, you will find out that you will feel warmth, you will feel heat in that region, a specific region, yes or no? No, it's not like everywhere if the heater is switched on that the whole earth would become hot. It's not like that. It would be a specified region, confined region. Yes or no, everyone?
Yes, sir.
Okay. So after that, same thing is with the electric field. So electric field is a region in which you will find out the electric forces. Suppose that if there is a charge already. So let me just explain it to you over here. Just a second. Okay. So if there is a charge over here, suppose this is a region of this charge in which this force will be experienced. Okay. So basically this is the region, this is a complete region in which if you take any other charge, that charge will force basically experience the force. If it is positive, it will experience a repulsive force, isn't it, everyone? Because same charges repel each other.
Yes, sir.
And if the incoming charge is negative, so it will get attracted towards the charge. Ultimately, both the charges are gonna experience the force that is either attractive or the repulsive, depending on the nature of the charge, isn't it?
Yes, sir.
That's great. So that's what the electric field is. And basically to show and to represent the electric field, we have basically developed a kind of you can say concept for the non-contact forces, because everyone, so electric force is a non-contact force. Basically it just kind of you can say that gravitational force, both are non-contact. So both of you are sitting right there in Saudi, but still you are exerting some force on me, even though there is no direct contact with me and you. Yes or no? As the universal law of gravitation says, right? Same, I'm also exerting some force on you. Everything that is not even in contact with me, it's going to exert some force on me, right? So it is a non-contact force. So we have developed a kind of theory, a kind of topic that is basically explaining the non-contact forces. So okay. So gravitational force is also a non-contact force. So that means it's also can be done with the gravitational field lines. Electric force is a non-contact force, so we can also explain the electric field with the help of electric field lines, because that's a non-contact force. So that's why we have developed it. It's a way of representation with the help of lines. Okay, so that's what the electric field line is. Please do let me know, everyone, if it's clear to you so far or not.
Yes, sir. It is clear.
Okay. Next is, just a second. Let me just erase it. After that, now let's talk it about. So electric field lines, in simple words, it's the way of representing the electric field with the help of lines. So suppose that the arrow shows the direction of the line of the electric field, basically. Okay. And these lines shows the intensity. What does it show, Bajo? It shows the intensity, that how strong the electric field is. Got it?
Yes, sir.
That's
Yes,
great. So
sir.
how strong the electric field is, that is shown by the electric field lines. And also electric field, the shape of the electric field lines matters. The reason is electric field lines of the uniform shape like this. Uniform shape means they are equally distant from each other. That means it is depicting that it's a uniform electric field. No need to write it right now. Just be patient and understand it carefully. Uniform electric field means that in this region, every point E is gonna same. Just like the gravity is always same wherever you go on the earth. Obviously, in like if you talk about the general like real cases, that's not same. But if you talk about the ideal case, right now we're just talking about ideally. So that's gonna means it's going to be the same electric field. Got it, everyone? So I hope this is clear to you
Yes,
so
sir.
far. Everything. Any doubt so far to you?
No, sir.
Sure.
Yes, sir.
That's great. Now let's talk about it. So basically, if there is a positive charge, so electric field lines are always away from the charge. This is the property of the positive charge. It always gonna away from the charge. And it is the lines are perpendicular. The electric field lines are perpendicular to the electric charge. Is that clear? So this is a property, and these are basically you know that whenever a line is drawn on the circle, it's perpendicular. This is the property of a circle or a sphere, isn't it?
Yes,
Is
sir.
always going to be perpendicular. That's the property. Okay. And it's always going to be is going to be away from the charge. And if it is a negative charge, so the electric field lines would be, sorry, this is a negative, electric field lines would be towards it. Is this clear?
Yes, sir.
Like this. And you might be wondering that we say that like electric, the same charges repel and different charges attract each other. Why? See this thing. The electric field line starts from the positive and ending at negative. Isn't it? They both are approaching the same field of line.
Yes, sir.
That's why the attraction property exists in the first place with the between the positive and negative charges. And if you talk about the same charge of the positive, are they going to attract or going to repel? Because they both are in different direction. If you are applying
So
some
they're gonna attract. So they're gonna repel.
repel, because they both are acting in the opposite direction. Suppose that you are applying forces in the opposite direction. What happened? They will pull it. You are pulling it away. You are not attract, basically keeping it up together. You are pulling it away. That means you are just trying to pull it, repel it up. Yes or no? That's why the
Yes, sir.
same charges repel each other. That's the theory behind it. The electric field line explains the theory behind the attraction and the repulsion between the charges. Is this clear, all of you?
Yes, sir. Yes, sir.
Okay, that's the basics of the electric field lines, and these are some properties based on that. Okay, now let's move it so that we can write some theory part of it, and after that we'll study more about it. Okay, so please note it down, Michu. Let me know once done.
Yes, sir.
I'll explain you that why the two electric field lines cannot cross each other. We'll discuss it. Just write it down first.
Okay, sir.
Yeah, that's great. If there is some word that is not understood by you, please let me know once. Okay, and one more thing, this is the short form of direction that I'll be using, so that's why you can use it in the notes but not in the exam, so please try to avoid that thing in the exam. Okay.
Okay, sir.
Yeah, that's great, because sometimes students use the same kind of keywords in the exam and teacher says that what is this, so please try to avoid that thing. Just use it in the notes so that you can have save some time sort of thing. Okay.
Okay, sir. Okay, sir.
And which one is your favorite subject, by the way, Tayyabe and Hadia?
Yes, sir.
Which one is your favorite? Like which is the favorite subject?
Sir, maths.
Maths. Acha, ha, I just checked your copy. Yeah, I do. I did. Like you were basically pretty solid and pretty strong in the maths.
Yes, sir.
Great, Tejas. That's great. Okay, that's great. Okay, Tejas, we'll discuss it in the class when we'll basically get together. Okay.
Yes, sir.
Okay, that's great. Okay, so now let's talk about it. Basically, the properties of the electric field lines. Right now, we are doing it. So, first thing is basically everyone. So now let's talk about it. Sure. Okay. Okay, bye, Tejas. Okay, now let's talk about it. Basically, the electric field line properties. Suppose that this is basically suppose electric field, some sort of curved lines. Okay, we are showing that it's straight line. Some in general cases it would be curved. So everyone, we know that tangent is the line that gives the direction to the circle. Yes or no? In the 10th standard, there was a topic of the tangent. Yes or no? That point,
Yes, sir.
tangent is a special case of secant, or you can say the chord, which basically when touches the circle at a specific point, and at one point only one tangent can be possible. Is this yes or no?
Yes, sir.
That's great. So if you basically try to drop a tangent on this, so one point will show one direction because tangent is basically is used to show the direction, isn't it?
Yes, sir.
That's great. But right now, suppose if a single charge is there, suppose if a single charge is there, okay, and the line rays, suppose that aligns and another charge is there, suppose, okay. So like these are like some sort of thing, okay. So another line that is coming from this charge cannot cross this charge line. The same charge, the two electric field lines of the same charge cannot cross each other. The reason is, suppose that if such thing happens, Bacho, this is a point of intersection.
Yes, sir.
What will happen basically? This two directions of the point are given to you. Is it possible that you can point out basically a point can basically point two direction or basically gives you two
No,
direction
sir.
at a single time? It's not possible. Same like so you can say that in simple words. It's not possible to be there in Saudi as well as in Delhi right at the same time. It's
Yes,
not
sir.
possible. By the way, you are not a fan of Avengers or the Marvel's universe. It's not gonna happen. Do you see? Do you watch Marvel universe?
Yes, sir.
अच्छा ठीक है. So you must have heard about the multiverse. That's what I'm saying.
Yes.
Yeah, ठीक है. Okay, so that's why it's not possible of the same charges of basically the electric field of the same charges cannot cross each other because it gives two direction and that's completely possible and violating the rule of maths as well. That's why. Okay, so that's the thing written over there. So I just wanted to explain you in terms of the you can say that the diagram. So I hope this is clear to you now. This is a very frequent question in the board's exam that why the electric field lines and same thing will go with the magnetic field lines. Why the magnetic field lines and both have the same answer? Because it's not possible to point the two direction at a single time. That's what it is. Let's do it right now. And after that, we'll basically, how much you have done so far? Till
Sir,
this
I
point,
have done just till point C and I
point
drew the
C.
diagram.
Okay, one more thing. Let me just give you one more thing. So basically, see this thing, there are two diagrams of the electric field lines, and more they are close to each other, relative density, the more it is showing that it is a strong magnetic field. If they are farther away from each other, that means the electric field could be weak. In that case, so the relative density, the separation also shows the strength of the electric field. Is that clear, all of you?
Yes, sir. Yes, sir.
That's great. Okay, so please note it down and just draw these diagrams so that we can just move to the electric flux.
Okay, sir. Sir,
Yes, Teba.
so in this point D, over here it's written positive charge and
And terminates. Terminates mean end.
okay. Sir.
So how's the weather in Saudi right there?
Yes, sir.
I heard that the weather in Saudi it's very hot.
Yes,
Like
sir.
it's touching 50. Is it serious?
No, no, sir. It's 35 degrees. That's it.
In the like afternoon, what is it?
So afternoon it decreases. It comes to 33, sometimes 30, something like
Hmm.
that. But sir, in the morning it's very hot,
Oh, I heard
especially at
that like
afternoon.
sure. I heard that the it's touching 40 degrees Celsius, 45, something like that. Is it? It's not true then.
No, sir. It's not this much hot over here. It's just like between 20 to 30. It is. That's it.
Oh,
Yes.
maybe it's maybe in Riyadh because I have a student. He's in Riyadh. He told me that it's going above
Yes, sir.
40.
In Riyadh, it's very hot.
That's why. That's why. Jeddah is very near to Medina and Makkah, so that's why the temperature is
Yes.
not that much high right there. Oh, got it.
Yes, sir.
Okay.
Sir, in the F point, what does
Hmm.
EFL means?
Electric field line,
Oh, okay, sir.
short form. Yeah. So basically, when the field lines of the same charges goes basically nearby each other, they basically exert some sort of pressure. Basically, they try to basically separate away, go farther away like that. Okay, that's why they push and they basically exert some sort of pressure on each other. Got it, everyone?
Yes, sir.
Okay, that's the next thing is
Sir, in
basically
H point,
yeah.
sir, in H point, what is this? Like electric field lines cannot.
Penetrate. They cannot cross through a conductor. If the electric field lines are there, the electric field lines only reside on the surface. It's not like it cannot pass through it, it cannot go through it. Okay, the electric field lines only originate from the surface and it will end at the surface. That just like that.
Okay, sir.
It cannot go through inside it. Just like the sphere is there, the field lines cannot go through it. Okay.
Yes, sir.
That's great. That's what is. Okay. So one more thing, what is null point? Basically, null point is a point at which the electric field lines is zero. Electric field is zero, I mean, sorry. So null point, you must have calculated some sort of quotient related to the electric, like null point, at which point the electric field is zero by this charge and that. Have you done these quotient in the electric field? That's what it is, null point. Neutral point, null point, 0 point. There are multiple names of it.
Yes.
Yeah. Done.
No, Samsung.
Okay, sure. Umaima, no, bache, you, it's like, what's it? I think he is left. Maybe.
Straight down.
Then that's great. Now just let me explain the last point. So basically, if the two charges are there of the different magnitudes are different. So that means Q2 is greater than Q1. Okay, in that case, bacho, the shapes of the electric field lines would be distorted because when the charges are of equal magnitude, the electric field line will not be distorted. But if obviously the higher charge will exert more force, yes or no, on the other charge. Suppose that two persons are there, they're fighting with each other. One with the stronger one will land a basically very high force punch, yes or no? And one with the smaller one, like not that much strong, like the if that person basically try to punch that man, there will be no effect on that. Yes or no? I'm giving example, don't take it seriously.
Yes, sir.
Okay, so what happens is that's why the electric field lines would be distorted in this case, and the null point, the point at which the electric field line would be zero, will lie near the smaller charge. The reason is because this charge will exert more force on this null point or kind of point because it will have a longer range, wider area of the field, electric field, isn't it? So that's why the electric field, null point of the electric field would be near to the smaller magnitude charge if the charges are there of the different magnitude. If of the same charges, middle point would be the null point. But charges are different, magnitudes are different. The null point will reside near the charge of smaller magnitude. Is this clear, all of you? So that's why it is showing that distorted form of electric field lines. So this is all about the electric field lines. I'm asking one more time, is there anything that is not clear to you so far, Hadia and Tayyiba?
No, sir. Like everything is clear to now.
That's great. That's great. So now shall we move forward to the next topic? That is our electric flux. Because electric field lines are important to understand the electric flux. That's why I've given you the idea about it. Okay.
Yes. Yes, sir.
That's great. Now let's talk about the electric flux. In simple words, the number of field lines passing through the area perpendicularly is called flux. Simple. If you have taken an area or a surface and through which the field lines are passing perpendicularly, specifically I'm saying perpendicularly, in that case, that will be called as electric flux. More the field lines, more will be the electric flux. Is that clear, Bachon?
Yes, sir.
That's great. Now let's talk it about, as you can see everyone over here, and this is a kind of surface. And when the basically electric field lines are passing through it, so obviously it would be forming the 90-degree angle to it because of the curved surface, isn't it?
Yes. Yes, sir.
That's great. Okay, so the formula of the electric flux is basically phi. This is represented with the chord of phi. In the 11th standard, in the sets, there is a chord phi. Same thing, empty set. That's what it is. Okay, basically the notation is same, but the meaning is different. Okay. E dot S, electric field into the area vector. Acha, one more thing, everyone. Let me just tell you one thing. So we have different shapes, right? So in that case, different shapes, the area vector will be talking about the area vector. The area vector will be perpendicular. This is the vector that is pointing the direction of the area. So if the suppose that, let me just remove my background and let me show it to you. Okay, now, okay. Suppose that this is your area, okay, or kind of surface that you have taken for the electric flux calculation, okay. So what would happen in that case, Bichu? Area vector, direction of this area is showing what? The perpendicular.
Yes,
Okay, if it is placed like if it is placed right like this, okay, it's perpendicular, okay. So the perpendicular
yes,
to this would be this, and if you're taking this side, so this would be this. Yes or no?
yes,
Okay. And if it is this, so it is basically coming towards you into the page or out of the page. Is this clear, Bachu? So that's
yes,
what
yes,
area
sir.
vectors is. It points out it points the direction of the area of the surface that we are taking for the electric flux calculations. Okay.
Yes,
Okay. So that's why it's important to make sure that electric field lines are perpendicular. Why? Let me just tell you. In that case, why? Let me just tell you one thing. So electric field lines are all in this case. So what is the direction of the area vector of this surface? In this direction or in this direction? These are the only two possible directions of the area vector of this surface, yes or no?
yes, sir.
In that case, Bacho, what is the angle between the electric field line and the area vector?
Yes, sir.
What is the angle between the
So
area
180
vector?
degree?
Okay, so let's take it one, let's take it two. What is this? So just a second. Let's take it one, let's take it two. What is the angle between the area vector one and the electric field line? Tell me
So it will
fast.
be,
Yeah.
the angle, like,
Angle,
so
yeah, angle.
it
What is the
will
angle
be,
between these two lines? Suppose that these are two lines. What is the angle between these two lines? That's what
so
I'm asking.
30 degree.
Okay. Tayyiba said 30 or Hadia said 30?
Tayyabe.
Tayyiba. Hadia, what do you say?
Sir, it might be. Sir, can you repeat the question again?
I'm saying, suppose that this is the line one, this is the electric field line. What is the angle between these two lines?
Sir, 30 degree?
Oh, but you 0 degree. Two lines are parallel. 0 degree नहीं होगा. देखो, this line and this line are these line not parallel to each other?
Yes, sir, they are parallel.
They are parallel to each other. And this line, they are anti-parallel because this is the area vector direction, this is the electric field direction. So in
Yes,
this case, if the electric field, we have to take the angle between the electric field and the area vector, not the area. Keep that thing in mind. Area vector, not the area. Is this clear? Area
yes,
vector, I'm
sir.
again saying it's between the area vector and the electric field line, not the area. So sometimes the question will give you the idea about it, that the angle between the electric field line and the surface of the, you can say that the plane is given to be 30 degree. That's not the angle between the electric field and the area vector. You have to take it. So it would be 90 minus 30. That is the complementary. Because when we will do that question, you will get the idea why I'm saying that. Okay? So I hope this is clear to you.
Yes,
Why?
sir.
Okay?
Yes.
So that's what the electric flux is. Okay, and electric flux is a scalar quantity. That means it does not depend on the direction, it just depends on the magnitude of it. And the SI unit of it, Newton meter per square per coulomb or voltmeter. So when we will do the second chapter, you will get to know that another unit of the electric field is voltmeter. So that's why it is your voltmeter. Okay, so, okay? Is this clear? Volt per
Yes,
meter
sir.
is the unit, so that's why it's getting voltmeter in the first case. Now let's talk it about, suppose if the electric field is it's some angle with the area vector. I'm saying the Abhi just have repeated the angle between the area vector and the electric field is taken, not the area of the field is area of the surface is taken. So this is theta. So how do I get to know it? Because I need the horizontal component because that is making the 0 degree angle with it, isn't it? So what is the E horizontal component? E cos theta. So instead of E, you will be taking E cos theta in that case. Is this clear all of you? Yes or no, Bacho?
Yes, yes, sir.
That's why it can be written as E delta S cos theta. That means it is the dot product of the electric field, the flux. Can I write this thing E cos theta? Isn't it E dot S,
Yes,
the
sir.
vector, the dot product of the vectors? If this would be E sine theta, I can write this thing E S sine theta. It can be written as E S E cross S, isn't it? The dot and the vector product, isn't it?
Yes, sir.
That's what it is. Please do let me know, everyone, is this clear to you or not so far? Like flux.
Yes, it's
Any
clear.
doubt? Any cross
No,
questioning?
sir.
Sure? Sure.
Yes, sir.
Please note it down. I'm sure that I'm not sure. I'm hoping that everything is clear to you so far. Like whatever we have done and whatever the session has gone, like however the session has gone.
Yes, sir. It was good.
Good. Sure, that's good. I'm trying to to explain as simple as possible because that's all the things should be good. And this is for the uniform electric field, everyone. Okay, the surface is uniform. Let's like it's a square surface. Okay, it's like that. Clear, all of you?
Yes, sir.
Okay. Now let's do it, and after that we'll go through the just the overview of the curved surfaces. It's a very
Okay.
important topic because most of the question comes directly straightforward from the electric flux, something like that.
Okay, sir. Done till I have finished till uniform electric field.
Okay, have you drawn the diagram?
Yes, sir.
Okay. Hadia, like Hadia as well. Like I think it was
Yes, sir.
Tayyiba's
I've
answer.
also finished.
Cheek. That's good. Now let's talk about the non-uniform or the curved surface electric field. Okay, if we talk about that, how do we find the electric flux through it? Because everyone see this thing. If the case is in the case of non-uniform, you know that the surface is not even like that. Okay. So what you have to do is basically we have to assume a small part, because suppose that like suppose that you know that it's a square. One, let's take an example, it's a square. You know that 1,000 cubes will be fit inside that square, isn't it?
Yes, sir. Yes, sir.
Now let's take uneven room. It's not square, it's not rectangle, it's not circle, something, it's very different shape. Okay, a piece of land that's not in basically continuous shape. Okay, will you be able to predict how many cubes or how many squares will be fit inside that land? Any idea about it? Because that's uncertain. There's no dimensions given of it.
Sir, almost like 4 elements.
In that case, you don't have the idea. What you have to do is basically you have to pick a small element. Let's say that each cube is taking this much amount of space. So what you have to do, then you have to basically add them up. That's what integration do. Integration का मतलब है add करना. Integrate. Have you heard about integrate? Integrate means you are
Yes,
just
sir.
adding it up. Right? Differentiate means you are basically splitting it up. So right now we have to add up. We have to find out how many cubes can be fit inside that thing. Okay, that's a way of example. Not take it that much seriously. I'm just telling you. Okay, is this clear so far?
Yes, sir.
That's why in that case, if the surface is curved or even the electric field is non-uniform, in that case you have to take the closed surface, because electric flux is always calculated for the closed surface, because we are not talking about the open surface, we are talking about the closed. So that's why it is called closed integral. You use integral normal. When you add the circular sign on it, it would become the closed integral. Is this clear?
Yes, sir.
That's why it is called surface integral, closed integral, like that. These are the words or the names given to the integral. Okay? So that's the way of representing the same thing, but in terms of the integration, because you have assumed a small part of it. Instead of ds, let's just a second, let's make it ds cos theta. I just mistakenly wrote delta ds. It's ds cos theta, because you have assumed a small element of ds. Is this clear?
Yes, sir.
Okay, any doubt?
No, sir.
That's great. Please note it down, and after that, we'll start do the questions related to that in the next class. Okay,
Okay, sir.
that's great. So, will you be coming to India in the vacations, like Delhi or MP?
Sir, we are planning to.
Acha, okay. So, like, you were you born there as well, or you have just shifted right there after the